Okay. Looks like we are good. We have broadcast bars, we have sound, we have music, which is changing right now. And yeah, looks like we are on, everything on. Oh, we don't have the... No, I do. So what do we have? Micron Build. Probably the number is wrong. Yes, it is. Doesn't really matter. Let's change it. Let's update it. Pixel. Let me do a test chat. Chat test complete. So text, let's go to oh. Yep, looks like we're good. Let's see if I did it wrong or Micron Plus, build, part 10. We're good. Okay, let me check my... Okay. Everything looks good. Okay, so good evening everyone. So we're gonna continue today with the Micron Build, part 10. So first of all, good evening, good morning, good day, good afternoon, good whatever for you. And how's everyone doing? So yeah, as I was saying, we're gonna continue with the build. So last time we stopped on the probe, and I actually found out that there's a jig to solder the probe. I actually found out a few minutes ago. We are not gonna print the jig, I think. We may see how long it takes, but maybe we can print it on a V0. Yeah, let me start it up and eat it up. If it doesn't take long, we can do that while we do some other stuff. If it does, it does. Okay, so I printed the part for the probe, so the probe holder pretty much. So basically it replaces the bracket, the stability bracket that we installed, and actually it takes an end stop, so we can install that and install the end stop while we print the jig. If it doesn't take too long to print, we can check that. So let's take a look into that. Let's start with that. If it does, I don't care. I can leave. I can solder the thing without the jig, no problem. Okay, so let's go to Brave. Well, actually, let me lower the camera a little bit. Yeah, it's fine. Let me decrease the so webcam. Where is the transform? Is it here? Yes. Yeah, this thing can at least a few hundred. Oops, sorry. Okay. Maybe 150. You know what? Let's just leave it, because sometimes I go on to another side and whatsoever. Okay, so I'm gonna actually go to big screen so we can open. So as I was saying, not this, not this. Where do I have? Okay, this is what we print. We close some stuff in here. It can be open, that can be open. Yeah, doesn't really matter. Okay, so let me go to cartographer. (3D). Add a current. So if you go here and if we go to documentation. Hey Joseph. Yeah, I'm good, I'm good. So here you have a bunch of stuff, like pretty much everything we're gonna need. And we have assembly. So we're gonna do a standard assembly. So this is the jig. We can download it. Oops. Let me open it on a new tab. Can download it. Fine. And so I'm running a test on my can I open? Yes, I can. On my Trident. Oh, it's ABS Plus. Oh shit. I thought it was regular ABS. So let me actually, so that's probably why I fucked up. The printer, the print part, well, the part printed, but not exactly how I wanted, so well, I can use this test anyway. Yeah, so let it print. So I selected the wrong, so it's supposed to be this one instead. Yeah, 245, 100 degrees, that's fine. I'm actually printing at a lower temperature. Yes, it's the same. Okay, pretty much the same thing. I'm printing at the 100 degrees, so yeah, I think we're good. Okay, I can take some input on the testing anyway. Okay, so let me open the second Orca. Let's open the Mini. Let me go to device and start heating up in case of we gonna print. And let's load. Oh, this thing is big. Nah, it's gonna take too long to print. Standard, let's go standard, boron. Yeah, 48 minutes seems like a long time for something that we don't really need. Yeah, we can do that. So we need 20 grams of filament. Okay, it's not much, but it's more than I have. It's more than I have in here, that's for sure. Fuck. At least that. So I only have a few turns in here. Let me grab something that I have more. Let me see. Here we have enough, and it's actually ABS Plus as well. So we're good. Getting the point. So yesterday I couldn't stream because I had an accident with my Trident, so I had to fix it. So if you guys are on my Discord, you know exactly what I'm talking about. It's fine. Basically, one of the palm nuts No, it's not a palm nut. Now it's a ABS nut that I 3D printed. And yeah, it's working fine. At least I hope it works fine until I get the new ones. So basically the palm nuts wear out. Well, one of them. Hey Beanie, one of the three wear out. Another one was pretty much dead or gone already, but still holding. And the third one was actually, I would say, with 25% left on it. So yeah, they were pretty pretty boned. These ones look good so far, so I 3D printed some, so just so I can have the machine working. It's my workhorse. So yeah, so let me select here ABS plus everyone ABS plus black, that's it. So I have in my shop, actually I have spares for TR8 with 4mm pitch or lead or whatever you guys want to call it. I have TR8's 2mm lead or pitch, but I don't have TR8's 4mm lead. So then I thought about making one. Benny. So I thought about making one, and I went to my thread milling, TR thread millings, and I can make a 2mm and a 3mm, but not a 4mm pitch. So yeah, that in a mortar. Anyway, I 3D printed some, it's working. Let's hope it holds. It made a 10-hour print today. There's no signs of any dust. And something I noticed it from the beginning, it was some dust on the nuts. I'm full of fur of my dog. Anyway, oh, let me turn on the other cable, the other camera. It's out of place though. Yeah, it's fine. And lights. Okay, so let's send this to print. And let's hope for the best. Do I have... Yeah, it should be fine. Okay, so meanwhile we can prepare end stop switch, and we can install the actual, well, no point installing the probe mount without the probe, so let's wait for the probe. But we can install the lead screw. We can do some crimping on the lead screw. We can install the end stop, and then we can do some crimping on the F connectors or the PCB connectors, since we're gonna need to do it anyway. So we can do that, and then we're gonna open the cat and see what we're gonna mount. Maybe we can mount the drag chain for Z. Let me check the camera. Okay, fine. We can mount. We press the thumbnail so the printer doesn't do crazy stuff. So it's heating up the chamber up to 35 degrees. So let's hold all the probe bits and in the box for now. I think it's pretty much everything. So this is the This is the old one, this is the new one. Slightly different. Well, if they are equal, I wouldn't need to print it, right? Okay, so this is the USB cable for programming and stuff. Anyway, so let me grab, oh, actually, we have one in here. So we have here, end stop switch. So this thing should be mounted like this. It only needs one screw, because they do a little pin on the printed part, so it will hold one place of the other screw, which it's not a bad idea. It's not the greatest idea, but it's not a bad idea. So this will be like that. Let me do a little chamfer so the pin sits better. So why do they do that? You guys may ask. It's just because sometimes the screws do some stress on the printed part lines, and this way you're just avoiding the part to break in there. Okay, let me grab some wires. Let me grab some silicone wires for this. Let me grab, where do I have? I think I have it in here, so give me a second. Yes, I do. I can see them already. Yeah, okay. Black should be fine. Let's use blue, just because. These are super thin. Yeah, let me grab the others. A little thicker. So since red and black are the most used ones, maybe some, yeah, but some dark color, brown. Let's use brown. We don't need them huge, I think. Something like 10 centimeters should be fine. We'll see. Maybe I'll zoom in a little bit. It looks good. So we are working here next to the X-Acto. So let's put in a bit of flux. So we are using the end pins let's use our super duper crazy fancy soldering iron, cheap soldering iron, which I like very much because it's so cheap and it works sometimes. Okay, it's heating up. Okay, so I did some more work on the Milo design. I mean on the covers, the way covers. Okay, looks like it's starting to move now. So I mean, it looks. Yeah, we reach temperatures. Yeah, the new style. So now I am in a. I'm in a. I kind of feel bad because I asked for a seller that makes way covers, and he made the way covers for my VMC, and he designed everything and it looks amazing. So it's basically a bellows, but with stainless steel covers on top, and it's not cheap. It costs about $150, the cover, both covers, so for both sides of Y. So, but I'm liking my design as well. So, and since I need him to make me some stainless steel sheets for my VMC, I may order at least a set to, I don't know, I feel bad for the guy having the work designing the thing, and now I don't want it. It's kind of bad. I don't like people doing that to me. So, but yeah, I feel like that I can make my design work. I thought about some details. So one of the things about the telescopic covers is that we need to have a way to wipe the ships. So the way the covers, when they move, they need to basically sweep the ships on top. So the one on top needs to sweep the ships from the one on the bottom, and so on. And it's not easy. It's easy to design that something in the computer that in ideal conditions work, but with plastics and 3D printers and whatsoever, the tolerances and whatsoever, it's not that easy to design something that actually works on the real world. But yeah, we'll try. I have some ideas. I need to do some testing. So we'll try that. Okay, now we need a screw. So I have the two ideas I have. One is using felt. So just buy a piece of felt, like 2 or 3 millimeters felt. It's super cheap, it's easily available. and just do some slots on the 3D printer on the 3D printed parts and then glue the felt on it. That's the first thing I'm gonna try because it's the easier one. The second one, it's actually printing some TPU wipers. Which I'm not sure if we can do it accurately enough. But yeah, that's the second thing I'm gonna try. That's why I'm... Let me see if this thing is... Yeah, looks good. So let's see if my ideas work. Hopefully they do, because I kind of like the idea of a do-it-yourself solution. Okay, so my test print just finished. I need to go grab the plate and examine the result. Print in place on that specific situation, I'm not sure. But it's an idea, which I haven't actually thought about, but it is a good idea actually. But it's yeah, on Scala or even on my, I prefer actually that on my Tridex. But it's actually a good idea. I haven't thought about that. I need to see if the design I made it's printable, because I designed it to be print on another orientation. We'll see. Sort. Okay, so let me check. So this is a flow test because I think I'm overflowing. It doesn't look like it. Everything looks perfect in here. Fuck. Oops. Gladly it's on the back. I was smelling burn. Now I understand why. Where is my... I don't have it here. Yeah, everything, this looks good. I don't feel... Yeah, it looks perfect actually. So let's leave it. Probably it was my... I was printing with a too hot plate. Yeah, everything looks fine. Yes. Maybe maybe only one piece needs to be changed. Yes, I think only one piece needs to be changed, which is the piece on the... So right on the front of the machine, on the y-axis, the end, where do you have the manual handle? It might need some adaptation, because I think the original... Yeah, I'm pretty sure. Shit, this is super stuck. So yeah, I think only that piece needs to be changed, and there's the issue with the corner of the full metal jacket side plates. It needs to be cut. There's no other way there. The only thing without the cuts would be making cuts on the on the on the covers as well, but that are, at least for me, it's not an option, because it will open it will open holes and chips will fall there. But yeah, it should work. It should work. Other than that, it should work on a stock model. Okay, so we done that. So now let's do some crimping. I turn off the soldering iron to save battery. And I need to think the idea about doing the multi-material on a multi-material printer, which is actually not a bad idea at all. But I need to check if the design will allow that. What do you mean, Marco? Is the two-country system? Well, it has the two-arm system. So better saying, it has a system where you have a lift arm on the front with the heads, and it moves up and down to get the heads away, other than just parking using the z-axis of the machine to park the heads. Okay, so let me open the... I need to check the EBB. Well, first I need to Yeah, let me set something. Just one arm. It moves up and down. It's not a fixed arm. It's a moving arm. Okay. Let me check. I need to start printing something on my Trident. So let me check if I have enough filament to do it, or I need to change the spool. Keep everything warm. Let me grab an empty spool. Yes, my Scylla has 6 heads. That's why it's called Scylla, or Scylla, or Scylla. I call it Scylla because I like it. It's mine, so I can call it whatever I want. So let me zero this. Ah, fuck. That's not enough. Not enough. Need 350 grams of filament. So I need a new spool. Shit. Okay, so let me start this one. Let me write. I like to write how much filament I have left on the spools. Where's a pen? Need a pen. Here's a pen. Okay, so 310 G. Yeah, I have 2 printers capable of multi-material. I have the Scylla or Scylla with 6 heads, but I also have a Tridex with 2 heads, which actually for 2 filaments, it's way more. My Scylla is not printing now. I need to fix it because one of the hot ends, the first hot end died. The heater died. They all do. So I need to, and I want to replace them all actually, and I need to do some testing. So after we finish the Micron, or it may be even sometime next week, because I may need the Scylla for another project. So we're gonna have some, maybe we do a stream with it, because I need to change all the heads for the bamboo style hot end, and then I need to retune everything. And actually I found out something I done wrong on my streams in configurations. Not serious stuff, but it's something. And so we'll need to fix that one of these days. What we have in here? Oh, we have black in here, a lot of black actually. Hyperspeed black. I can use this one. Hyperspeed is good. And my Tridex right now, I can print with it, but yeah, we'll use this one. So give me a minute. So while I load this one, me check. 80 to 110, okay. So my Tridex, I need to set the, need to do an update on the macros because I really want to use only one slicer, and I have everything set for Prusa slicer. And actually on this new computer, I haven't installed Prusa slicer yet, and not sure if I will, because like I said, I want to use only one slicer, and since Orca is multi-material capable already, I want to keep everything on Orca because I love Orca and I hate Prusa slicer. And I need to do a system on my Tridex to fine tune the second head, but I need to design it first and then we can install it. Okay, everything decent. So let's go to, no, not Orca. Could be, but it's going to be a pain. So let's go just to the screen. Okay, I don't want this Orca, I want the second Orca, which is this one. Yeah, this one. So let me open new project, and I don't want to save this project and discard everything. Let me load 3D printer models. Not sure if it's here or here. Yeah, I don't see it here, so it should be here. Yeah, BT40. So I need to print this thingy. Let's go like that. I want to print it in 0.3 layers. That's fine, and it's ABS, HS, high speed. Let me check. 250, everything 100 should be fine. Let me check the plus. Yeah, I want the plus at 100. Oh, 100. Yeah, let me put everything at 100. This is new to me. Fuck. For now. One day I need to set everything in here. At least everything I use. 245. That's fine for the plus. Okay, ABS, high speed, hyper speed actually. Yeah, that should be fine. Let me change this one. So I'm using the textured plate, yes. Orca is becoming super cool. Slice plate should be a 10-hour print or something like that. Oh, no. I want these on standard Voron. Yeah, let's transfer and slice again. Tridex is a little... well, they're both different projects. First, I had a way less experience when I did the Tridex and when I did the Trident. The Tridex, there's not much information. That's why actually now we have my stream for the Tridex. And for the Skyla, there was no information at all. I had to figure out pretty much everything on stream. It's different, of course. The Skyla was a little different because it was more... we have 6 heads, but it's pretty much do the same thing 6 times. The Tridex, it's so much easier with the macros from... I don't remember the name of the guy, I'm sorry. Yeah. Joseph Garner, I believe. I think it's Joseph Garner. Actually, it was a lot easier. I was very scared because it would use some kind of different version or a specific branch of Clipper and whatsoever, and that just uses regular Clipper and it's based on macros and it works stupidly well. So yeah, 10-hour print. Let's go. So yeah, 2 different animals, both difficult. It's not like a first build thingy for someone. But yeah, they are both fun projects. And to be honest, I kinda like the Tridex more than a Scylla. But it's different. It's just different. Because on a Scylla you can, on the Tridex you can print 2 things at the same time. You can literally print 2 parts at the same time. It will take as the same time as making like it's 2 printers, as long as they are the same, of course. It needs to be equal or symmetric parts, or equal or mirrored, symmetric, the same thing. It's super cool to watch. Never gets old. And of course, the Skyla with the stealth changer, it's also super cool, seeing the tool changes and whatsoever. But yeah, it's different. I like both. I think I like the Tridex more like working, but if I had to choose one to make, and only one, I would take the six-headed beast, the Skyla. Stealth changer, it's not that bad. There's a lot of info. The thing with me, it was I was the first one doing the... well, I wasn't the first one. The first one was the guy who invented it, but I was the first one on YouTube at least, making the lift arm thingy. I think now is a newer version with dual loop instead of single loop with 2 motors. Actually a dual loop. I haven't looked into it, but I think there's that now. But I don't see the need of upgrade that. I like the nudge probe. I'm going to install the nudge probe on my Tridex as well, because the thing is amazing. It works super well. So yeah, it's just different. It's just different. Anyway, let's continue. Meanwhile, how is our print on the... it's 50%, so we are doing fine. How is it 50%? Yeah, okay, makes sense. chamber at 45, which is super good at an 85-degree heat bed. Why am I using only 85? Oh, it's ABS Plus, right? Yes, it's ABS Plus. Makes sense. Okay, so also it's time to open the car. Oh, actually I have the car. Oh, so this is the nut I had to design yesterday. At the first time, that was the first, printing threads accurately at the first try. Okay, so Micron. Yeah, we need a R1 card assembly. Let me check the first layer, because the first layer is the key. Yeah, everything fine. This printer usually disappoints me, but sometimes it does. Okay, we have the card open. I want to check the screen. I'm not sure if this uses a 3.3 or, so not this one. So this is the default 3.1. Okay, it's a 4.3. Okay, I have one there to use. So we're good with that. What else? Okay, what I need now. So I'm going back to Brave. Is I need to open the EBB. It's kind of hot today in here. EBB 36 GitHub. So I think it's this one, doesn't really matter. Is it? Yeah, it's the B1. G0 B1, yeah, that's fine. So the 36, probably the user manual will do fine. I just need to put a little coolant in there. I think I have those. Yeah. More pages. Almost that. Yeah, that's pretty much what I need. Okay, so I need, oh, that sucks. That's fine. So the thermistor should be in here. Can connect that. I'm not even, I don't see a problem. Let me push this thing all the way back. Yeah, it's fine. So we can connect it. Oh, let me change to the main camera. So we have the thermistor connected there. So we need to connect the pot end in here. So it can be directly there. I'm gonna cut off the tweezers. We need a very small flat driver. Something like this. 2 millimeters should be good. Let me see. Actually, it's too big. Let's go 1.5. Yeah, that's fine. Holes are open. Now the 2 millimeters should work. You want it yeah, 2 millimeters is perfect. So we're gonna actually, I think we can use a little more strip. Let's go here 0.5. Yeah, make it a little bigger. This one first. Yeah, that's fine. Jesus, what's going on? So we have the heater in here. Good. Now, what's the 3-pin? RGB. Okay, so RGB. RGB. We need to pass it through here on the middle. And going there, some spare, so we can cut it somewhere here. And we need to crimp GST. So this is super thin wire. Should be easy. Should be easy enough. Or where do we have the box? Is it here? Yeah. Okay, so before I forget, let me put in the heatsink, which should be there already. So the heatsink, it's gonna go to the stepper driver. Ow. Like that. Now crimping the GST. These are the regular ones, so they should be easy enough to crimp, especially with this super thin wire. One done, two to go. Two down. Okay, the worst thing about this is actually seeing the yeah, okay. That's why I was having problems. Seeing when the wires get in and not the okay. Not the insulation. Yeah, that's fine. Okay, so we need a 3-pin one, which is this one, and the order should be 5 volt on top, so like this, so red, is on top, and since the wires are so thin, I have actually to press in the connector with, or the pin with the tweezers. So we have the signal on the middle, which is the green, and the black, like that. I'm gonna actually twist them. And connect it like that. That's done. Now these two fans should need to be on the same connector. And it doesn't really matter which one goes where. So since these wires are smaller, I'm gonna put the hot end fan on fan 2, Now here's another thing. We have 3 wires in here. I'm pretty sure the blue one is the tachograph, the tachographer, so RPMs, the speed meter basically, which we don't need. But if we want to connect it, we could connect it on one of the end stop pins, I think. It would be nice to have just so the clipper would know if the hot end fan dies to stop everything, but I'm not too concerned about that. So not sure what I'm gonna do yet, because the wire is too short. Well, it's not. It's basically right on the size. So I may connect it to the end stop 3. Let's see what they say about connecting a 3-pin fan on a EBB. Do they show it here? Let's see. Nope. More pages. So this is the BL Touch. We don't need the BL Touch. What's this? Okay, filament run out. We don't need that. RGB lighting is connected already. So this is clipper stuff. Pretty sure. Clipper configuration. Yeah, okay. So we don't have anything in here, I'm pretty sure. Let's see. So 3-pin fan. EBB 36. I think it was Beanie back in the day that, yeah, that's pretty much what I want. Let me see what we have here. Okay, so this is the guy basically asking the same thing. Supposedly should be fine. Okay, this is exactly what we opened. I remember, give me a second. Give me a second. Okay, I'm gonna use the main camera here while I open Discord, because I don't want to open something that I shouldn't show. Yeah, and I would. Oh, so if I remember correctly, somewhere in here, our good friend Vinny Yeah, nothing. We wouldn't get anywhere. But yeah, I'm pretty sure it should be fine. We'll see. So let's continue. Something stopped. Oh, it's my V0. Just finished the print for our jig, which actually looks good. Yeah, same story. It seems a little, it's either over extruded or warped. I'm pretty sure. Yeah, it's fine. It's fine. Let me check how is my... Looks good. First layer. It's looking good. Okay. So let me check if the pro pieces fit together or fit in here. So this is supposed to be... Jesus, this... They made it way over... Way too much play. But yeah. So we have a jig, so we can do that. Well, we can do that now or, well, or later. Okay, so basically, one thing is sure, we can use, I can route these two fans to the center. I'm gonna, yeah, okay. I was about to cut the yeah, exactly like that. But since I was about to cut the connector, because it would be way easier to pass through just the wires without the connector, but I like to save these connectors with the wires attached, because sometimes I need a piece of wire with this GST connector, and this way it's just easier to So this one will fit on both sides. So let's go to where's the ABB? Pin out. It's here. Yeah, let's go. The part fan's going to be the fan 2. So together we can cut them here. So yeah, sometimes I need this stuff with connectors, and so I like to save, or with wires, I like to save them. Good night, Beanie. So let's split it. Okay, let's split it like that, and let's strip the wires, and let's see if I can crimp the wires both on the same connector. Should be able to. It's not the first time. Let's go. Grab 2 GST connectors. Let's prepare it on the pliers. So what I like to do with this one, so I use not the bigger one, the second one for the GSTs. Since they are ratchet, what I do is I start it on a first click. I think it's the first click. No, it's actually the second click. I prepare the connector, and now I have the connector in place. Hey Roberto, how are you? And now I'll put in the wires. Actually, I'm gonna stretch it a little more. So both blacks. Yes, this is iWis. This is the iWis IWS 3220M. You probably use that one that looks like the engineer. Okay, the wires are not too big. There we go. I can see the hands. Let's go. First one, success. Hey, AAA. Yeah, I had, actually I'm not sure, I still have one, I believe. Yeah, so probably the iWish you have, it's this one, right? I don't like this one. At least mine. I see so many people saying good things about this, but I can't. Mine are not grounded straight. So where it does this, they are not grounded straight. And every time I close it, it's gonna mess up with the pins. And I bought two because I thought the first one has a defect. The second one, it was exactly the same. So I only use these exactly for the very, 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 very small GSTs, like the 1mm pitches. And this thing is amazing for... It's just amazing. It never misses unless I fuck up. I meant to buy an actually engineer one, a PA9, but they are not cheap, and I want to, but okay, this one was much easier. Yep, there we go. There we go. Just like that. Yeah, Japan is the thing. I have one of this kind of engineers, but this one is also very good. This is top Forza. It's Taiwan made. It's very good. But the engineers has a different touch. This one works perfectly, don't get me wrong. But the engineers, it's the touch, the feeling is different. Okay, so we have 24 volts on bottom, so we have the red on bottom, should be on here. So red should be here. Yep, black should be on top. Oh, and I have a problem. Yeah, I need to grab... Okay. Because these delta fans are... these delta fans are 5 volt. And I almost forgot about that. So this thing should have come from the other side. So the delta fan, I'm gonna keep the connectors, the wires full size. I'm just gonna connect since the ends come thinned, just in too big, I'm just gonna connect those. Okay, so that way where can I grab? So I can grab two. Okay, let's do the probe first, then we figure out these later. It's gonna be later in 10 minutes or so, but yeah. So let me set these aside. And let me aim back. To the floor in here. And let's grab the probe. So this is the USB cable for flashing and whatsoever. We should need it. This is the cables that we actually going to use, probably. I'm saying they are too stiff. I don't like this stiff stuff. Okay, so if we check the manual, let's check the manual to check how to use the probe. Okay, so I printed this jig because we're gonna use this jig. So they say we should print the jig first, no special printing instructions, that's fine. Coil bars and pins, so we should put the coil board with the teats down. Yes, that's what they look like, teats. And with the very small jumpy jumpers. Oops. Okay, so with the teats down. So you see the two teats, little teats, go down. Then we put in the jumpy jumpers. And then we should put in the MCU board. And they should be, so there are a few ways to check how this is supposed to be. So first one, it's with this square on the square sheep on the PCB to top. And if you check this side has some squares around the jumper pins, and those squares needs to go down to the plastic. Also the ADXL should go down. So basically it's like this. And everything should align fine. Now we can solder the zoom in a little bit more. Can I keep focus? No, I need to go back a tiny bit. Yeah, I think it's focused enough. Let me put this on center. There. Okay, so I'm gonna put some flux, good flux, not shitty flux. Because flux is your friend. No such thing, well, almost never. There's no such thing as too much flux. And I need my soldering iron. Heat it up. Let's grab some solder. 200, 250, 280, 300, like that, like that, like that. Let me grab some alcohol, my Q-tip. Let's see if I don't scar my printer again. I scarred it down here a little bit. It's on the back, don't care. Where is my, it's here. Grab my swab. So we can clean up the flux. It's fine. It's not fine, but it's fine enough. Need more. Now we should be able to grab everything, flip it, and install it here. And now, same story, Flexi, Flux, like that. Boom. Can clean. Need to check the orientation of the connector. We're gonna check in a minute. Actually, this jig is cool. It makes it very easy. And they have jigs for all your orientations, so you just need to select whatever orientation you're gonna use it. Okay, that's fine. So let's take a look again to the assembly. Okay, so now we flipped and we soldered the pins. Oh, actually, we soldered the order. They actually said, I like to do that, to go the further away points. Nah, you're not late. You're fine. I'm glad you're watching Steve. Steve is awesome. I haven't watched him in a while. I haven't had the time. He was the guy that put me streaming anyway, so that's fine. Okay, so now we have to put the connector there. So the straight one. And what's the orientation? So there's two ways we can check the orientation of this thing. One is on pictures here on the site, so they have the ding of the connector towards the probe. Another one, and to be honest it's even more bulletproof, it's actually shit, it's not this one, it's this one. It's actually check the cable. So you want the red to be the 5 volt. So if you put in the, so the cable goes in like that, like that. So you want the, and you check the silk screen, where is the 5 volt, and the 5 volt, it's the last pin, so next to my finger. So it means that the red needs to be there. Like that. And yeah, that's the orientation, so it's fine. But let's say the guys made this cable wrong, and you could fry your device if it's not in a proper orientation. So again, we put it in, flux, solder, iron, one, two, three, four, done. So let me turn off the, I don't think we need it, at least for now. Put it away, clean it. So in case you're wondering, the flux I'm using, it's from, I ordered from AliExpress, of course. It's from a brand called Mechanic, which is a nice brand for electronic stuff. And it's the UV559. They have another one. Oh no, actually this one, it's a Kimbo fake, which sucks. This one, it's actually very nice. They have a, so it's this one, where it is, UV559. They have a new one, which I ordered a bunch of syringes to test, because I use a lot. It's very clear, it's supposed to be very nice. We'll see when it gets here. I'll do a test. Make sure the sensor is proper clean, not sticky. Need a piece of, yeah, it's fine. And we don't need the jig anymore. I'm gonna put it in a box of carton, because we never know when I need it again. Okay, it's fine. I'll put this away. I'm gonna zoom out. Zoom out. I'm gonna re-aim. Now, as I said, I'm not sure I'm going to use... I like softer wires. Where is... Should be here somewhere. Oh, it's here. Okay, so our probe mount. So we need to mount this thingy like that, because it's gonna mount like that on the printer. I have no idea how are we supposed to hold this. Not sure if it's let me check with the M8 M3. Okay, I see. Okay, so these are supposed to be old with nuts. So let me grab some M3 lock nut nuts. Where are they? I know I have them somewhere. They are here. See them. Yeah, I'm gonna use lock nuts. Yes, lock nuts. Because it's a 3D printer, it's shaking a lot, so where is the goddamn... It's here. I may need to use an M310. I'm not sure if I have enough threads to... Yeah, I don't think I do. Barely. Yeah, maybe I do. Maybe I do. Yeah, actually I do. Barely. So M38, it's barely enough, but it's enough to use lock nuts. If you use normal nuts, it's perfect. Even probably even M36 is fine. But I like the extra safety of the lock nut. So what I'm doing with to tight this is I'm sticking a flat driver between the printed part and the nut until the nut rotates and forces on the flat, and it will tight without needing of pliers or a wrench. Okay, we are good. So yeah, we can either use this one, the original one, which has some nice DuPonts in here, so I think I'll just use my own. Let me see if this thing is enough, at least. I think so. I like to think so. Okay, let's remove the bracket that we installed before, because this is going to replace it. So remove this bracket and install this instead. Oh. Okay, so this is, oh, okay. Okay, I'll remove it. I didn't saw that one coming. Okay, I need to remove the probe just because this thing is double. We could just hold it with 2 screws, but since we can hold it with 4 screws, let's do that. But for that, I need to remove the probe. Motherfucker. Because I need access. I need access from the bottom. So we need access from the bottom to install. I would like to show this on camera, but I can't. So we have 2 screws here on top that goes directly to the carriage. Like that. And I need a regular M2, not M2, 2mm. Where do I have? Yeah, I think one is here. So a regular L shape, and it goes actually through the screw of the probe. So the access to this screw it's from the screw on the probe, so I need to put in the screw like that. Maybe if I put this thing more to the, like that. I'm gonna just leave it finger tight. M38 works fine. Just gonna grab it with the tweezers in there. Yeah, like that. It's actually well designed. What? So now actually I should have done this before. Yeah, it's fine. Can do it now. Pass the wires from the switch. I'm gonna pass them through the zip tie I have already in place from last day that I haven't closed. So I'm gonna push it through the belt. Like that. Okay, let's make the cables for the USB now. I need to check where can I connect. I will need to connect 5 volt and data. I think these ones are data. See in a minute. So I can install the other 2 screws now. And I still need to tighten the top ones. I just want to make sure everything is properly aligned first. Okay, I can tighten everything now. Can I? No, I can't. I'm gonna untie this one and tighten it again. Same here. Yeah, it's fine. So now we can install the probe for groove. I'm gonna put in the okay, now I need a 2.5. I can use this one for now. Where is the 2.5x? That's not it. 2.5, it's here. No, actually it's a 2, not a 2.5. Oh, it's the same one, yeah. Stupid. Of course, I lost a nut. Ah. Tweezers. Tweezers. Ah, the fucker. There we go. One done. Let me find try to find where it went. It's here. Jesus. Things are alive. I have a feeling I'm gonna lose this nut for good. Not sure why. Yeah, it's cut already. Okay. So now I'm gonna use the same trick. I'm gonna just push the flat there. That's fine. Now this one. This one would be better on this side, because when it rotates the nut, it pulls against the it pushes away the flat. That's fine. Super tight, won't go anywhere. And now we just need to make some wires longer, a little longer this time. So I'm gonna do the original colors from USB. I'm gonna leave a little more wire this time, something like 15 centimeters, and we'll see then. So 15. So we're gonna go red, black for 5 volt and white and green for data. And it's not actually USB, it's CAN, so yeah, sure, why not? Let's do red and blue, green and blue. That's it. Crimp. So this one, it's a different. We need to grab our. It's a different GST type. Smaller, of course, because wouldn't make it easier, only harder. 3 and 1 more, 4. We have still 2 to spare. I have a lot more. I have a box of them. Probably 1,000 more. Okay, so this doesn't need much. Yeah, that's enough. About 1.5 millimeter strip is fine. 0.6 millimeters, 22 gauge. It's probably 24, but 22. Stripping just fine. Does it say in the box? 28 gauge actually. Silicone wires, which I love. So on these ones I use the second smallest not the second biggest. Not sure if I'm gonna be able to fit. Yes, I do. It's there already. I see it. It's beautiful. So the way I do it, I set the thingy on the pliers fully set, and then you need a good eyesight for this. Then I put in the wire and I check on the other side. When I see the end of the strip wire reaching the connector, I go in and it's done. Let me do some adjustment. Ouch. Good. Fuck. Oh, it's in my slippers. Is it? Fine. Okay. You need to write those down because I'm gonna need your help when I get to that point. So be sure you document everything. Since you're doing it, I will appreciate every help I can get because I know nothing about Linux CNC, so there we go. Oh, that should be fine. That's probably a shortcut or whatsoever problem, right? Okay, let me grab the original. Okay, so let's set as the original. I'm gonna go black there. Then I'm gonna go red on this side. Oh. So probably the shortcuts are related with the page where you're using. So make sure you check that. Okay, which one? Let me check the wiring. Installation and setup. Should I? Before you begin, Okay, hardware setup. Okay, that's interesting. Yes, it is. Yeah, it should be fine. Okay, cable routing. Okay, the thingy as the thingy there or not the thingy? That's something I should have seen before. I'm pretty sure. There's nothing there. Or is it? I think so. I think there's a termination. Termination. Oh, okay. I can measure, can check, so I'll measure. So let me check if we do have 120 ohms between the can lines, because I'm not sure. Need ohms. If no, we definitely do not. We definitely do not have. Okay, that's fine. Just wanted to know. Doesn't matter, we don't need it. Okay. Don't care about the mount, care about the wiring. Oh yeah, that's what we need. Okay, so white is scan low and yellow is scan high, which on CAN, if you have a termination resistor, so on your CAN device, if you have everything disabled, everything disconnected, on a CAN network you should have 60 ohms resistance on the CAN lines. That means you have two 120 ohms resistors, one on the beginning of the line or the network and one on the end of the line. So to check if you have your termination resistor plugged in, if you check your device lines, you should get 120 ohms if you have the resistor. If you don't, you have a different higher value. And when you join two together that have the 120 ohms resistance, then you get the 60 ohms on the across the two data lines. Yes, across the two data lines. Okay, so I'm going to use green as plus, so as CAN I, not plus, so data plus basically. So that's what I was checking, if because there's a jumper on the cartographer, probably on beacon as well. No, not on beacon because beacon doesn't have CAN. But on cartographer you have a jumper that if you solder that jumper, it will activate the termination resistor. And I was checking if mine was, this version supposedly is off by default, but well, never mind, doesn't hurt checking. Okay, so now I need to route the wiring, which is going to be fun. So I want to go there. And of course I'm going to try all the same time because yeah, programming, probably if you run into communication problems, it's because of that. Because probably the car key doesn't have the so I assume you are programming them via CAN, and I assume your device, your programmer, whatever, has a termination voltage, termination resistance or resistor, whatever you want to call it. And probably your card key, the key sometimes doesn't have it, and you can get it to work sometimes. But yeah, you can run into problems if you don't have the 60 ohm between lines with both devices connected. Okay, so now I need to pass them through the zip tie. I know you guys can't see shit, but nor can I. So Yeah, let's try like that, or like that even. So basically I have a zip tie in here, which I shouldn't have closed as much as I did, but I did, so now I need to deal with it. And I'm passing the wires through it. So all four are in. So you have pretty much all the wires route, so I can actually tight the zip tie. Okay, so now on the now so red, green and blue should come here. So let me check if if I route them through the middle, I can get them up there. I'm glad I gave it a couple more centimeters, because I said 15 and I gave it like 17. And I can tell you they are not too long. Yeah, soft. That's the problem with soft wires. They're soft, so when you need them to go to somewhere, there you go. So from here, yeah, we are good. We are good there. Long enough. Not too long, but long enough, definitely. Let me cut this little guy. So this thing is supposed to click somewhere. Let me check that. Yeah, there. It clicks there. which is fine. Ooh, what happened there? I didn't like that. Oh, I see what happened there. Shit, it ripped it out. Okay. Shit. Ripped it out, ripped it out. Shouldn't, but it is. I didn't like that. Need to put some zip ties in here. I need to re-crimp this wire. I'll explain in a minute what happened. Didn't like what happened. Go away, pa. Okay. Here's another one. Probably I'll need to undo the zip tie to make sure it doesn't happen again. So looks like the cable shouldn't pass behind. Well, it's a bad idea anyway. Yeah, I'm stupid. Sometimes I'm... Okay, so I need to redo that zip tie because I need to remove the wires and reroute them. So no point suffering. I'm gonna pull them down. Okay, it's a bad idea for the wires to pass between the belt and the rail anyway, because that way they will wear in the rail. I didn't thought about that. I didn't thought about that. So let's redo them. Come on. there. Fine. So I'm not going to connect it this time because there's no need for connection yet. So I need to rotate the printer just so. I pull the wires to the other side of the belt. Okay, I'm gonna connect it because I want to see the right length. Okay, I need to pull the rest. A small Allen so I can push the wires. Yeah, not much room to pass the wires, but it is what it is. Let me grab a new zip tie. Let me bend the point. Like that. Everything there. Ah. That would be something. Well, that's gonna be another fun project. I'm actually looking forward for it. But next, we need to focus on Milo. It's our next adventure, so it's good enough. Looks good enough, and now no more problems should happen. Yep. There we go. Let's see if this one is the last one there. Okay, so now again the blue and the green need to pass through the center. One. Actually, I should twist these two wires together, but should be fine. You can twist them now. They're next to each other anyway. Oh, actually I should twist them before I connect them, because they are. Okay. I'm gonna cut like 1 centimeter out of them. And so these are the ones that I love the most to crimp, which are DuPonts. I fucking hate them. Should be fine. Let me grab the DuPont crimper. I think it's this one. Yes, it is. Do we have DuPonts in here? We should have, but we don't have. So let me grab my DuPont box. Where is my DuPont box? It's down there. Huh. Yay, another CG. So, oh, I was about to say I don't have dual, but I do. It's like I need more. How are you, another CG? Okay, so how is this thing works? So it's like that. Actually, I'm gonna move everything in here. Actually, a little bit to the front. Fuck. Where are you? Okay, looks like I need to open it. Oh, actually it's good. Okay, it was good. Yep. It's bueno. It should enter fine. So it's like that. So DuPont's iWiz will do it. The thing is DuPont's, but it won't do it correctly. DuPont's are different. So iWiz only do that crimpy like that, and actually the DuPont's on the back are like that. So it will actually grab the cable, the insulation, like this and not like this. So yes, it will crimp them, but like that, so it won't be proper. It won't be proper. This one actually is specific, because if you see the back of it, let me try to show the back of it. Where's my touch screen? So let me try to show this guy in here. Okay. Let me decrease the light. Now let me try to focus. Where is the focusing wheel? So you see the top, it's actually round, while on this side it does the two valley thingy. So yeah, this is a proper DuPont. So that's a proper DuPont, that's a specific DuPont plier or crimper. But yeah, I understand. I only bought it because I had a project. I had to crimp like 200 of these thingies, and so I decided to order it. But I understand DuPonts are not the most used connectors on 3D printers. So, okay, so the can high, it should be, so the can high is the green, it should be on the right, looking through the back, so it should be here. And we can connect, well, we can connect these two to DuPonts, but here on the I2C, connector. So yeah, we can also bring them to the middle. Where's the black? Black is close. It's there, I see it. Actually go here. And go there. So same amount, gonna cut like 1 centimeter. And let's do them as well. And DuPonts actually are harder to crimp the back exactly because of that. Since the if you watch them, they are not like two squarey thingies. They are like something like this. So they are actually misaligned. They are actually pointy. So when they cross like that and not like that. So they cross on, so something like one side is these two fingers and the other side is these two. So when they cross, they pass through the one through the other without overlapping. And since they are pointy, they tend to not go straight. They disalign through the thingies, through the jaws of the plier. Yeah, they are messy. If you do a lot of them, yeah, I recommend to get the specific pliers for it. The number is also from iWiz. So these ones are the SN025. And yeah, I'm a tool junkie, so I like to have all the tools. Proper tools to the proper job. But I only bought it exactly because of what I said. I had a project that I had to crimp a shit ton of them. Perfecto. Let me grab another tool. Actually, I'm not sure. Let me check. So we are following the wiring diagram here on the cartographer website. So they are telling us to connect there. Let's check what's there. So there is the I2C. Okay, so that's fine. We are not connecting anything else in there. So we are good. We can actually use a 2-pin. Okay, and we have 5 volts on the outside. So it's gonna be like that. A cover would be nice for this thing. Okay, so now we have the fun thingy. So the fun thingy I think we're gonna use. So I think we're gonna do something different. So I think, I'm not sure if we can, but I'm gonna try it. So where's Brave? So since we have the here on the end stop thingy, we have 3 end stops. We can, and we're gonna use the 5 volt, and we need to signal pins. So I think we're gonna use the delta fan in here, and we're gonna use 5 volt and stop 1 and stop 2 for the fan, and then we connect the probe. Oh, we can't connect it here because the probe is GND and the probe is ground. Well, it can be active eye, but it's not the greatest idea. So, well, we can put the probe on the other two. Not the probe, the end stop. So I can put the fan on 5 volt, stop 1, stop 2, stop 1, stop 2, sorry, I was speaking Portuguese. And the end stop on stop 3 and ground, and we fill that connector, and that's fine. Yeah, let's do that. Let's try that. Not sure if it's gonna work, but we can try. So we need this connector in here. I'm gonna disconnect the power for so I can check how this thingy goes there. So it's like this, right? Yes, it is. Yeah. Okay. So let me crimp this thingy. It's gonna be fun. So we need 5 of them. Hopefully. I don't feel it's gonna be easy. Okay, so this is the small GSTs, of course, to make it easier. So I need... Oh. One done. These are not too bad since the wires are very thin. Hey Bob Booney, GSTs, but smaller ones, PZH or PH or whatever. It's not the GSTs, no, the PH are the normal ones, right? These ones are not the normal ones, under the normal ones. Where is the box? Should have a box. I think they are ZH, these ones. No, the PH ones, yes, that's the big ones. These ones are smaller. I think these are ZH, I think. Where do I have? Okay, I have the box, but doesn't say. So these are the ones that to remove the connector from the plastic, we need to lift the plastic barb to remove them and not to pull down the metal barb to remove them from the plastic. So these are the small ones. I think they are 1.5 millimeter pitch, while the PH ones are 2 millimeter pitch. And then there are two 1.25 ones and even 1 millimeter ones. Those are freaking pain, which are the ones that on the webcam. Fuck! The wire moved when I crimped it, so garbage. The wire slipped. I think these are ZH, not sure. ZH, ZR, something like that. Yes, this is a Micron. So it's Jesus, I barely got it. But it's there. It's fine. It's not gonna go anywhere. So it's basically a Voron 2.4, but miniature. So sized down into, oh fuck, not these ones. These ones, yes. It's 15 extrusions. Everything is mini in here. 180 print size. Yeah, you need to ask the guys that designed the PCB, not me. I would understand they would use everything small, but yeah, basically I think they are trying for the standards. So they use GSTs regular on the fans and thermistors, which usually the fans come with GSTs and the thermistor as well. Then they use also GST pH, the normal one, on the RGB, which usually comes with that as well. They use the pH on the motor, which they come as well. Then the custom stuff, they go custom, but this is a EBB 36. So we need, what are we doing? Oh, the fan. So we need 5 volt. 5 volt, it's the first one. Then we need the negative, it's going to be the stop 1. So we can control the speed. And the blue, it's going to be the stop 2, so we can check, hopefully, we can check the speed. Yes, it's going to be CAN boost. We could use it as USB, but no, it's going to be CAN boost because we're going to use cartographer probe as well with CAN boost. Okay, so now we need this guy. So this is going to be the X stop, which I'm going to need to pass it through somehow, somewhere. Where are you from? Bob Bunny. Okay, so USA, the States, in every way. So you guys have the Super Bowl today, right? It's supposed to be a big thing there. Yeah, I'm not a sports guy. Fuck, I forgot I had a thingy red in here. I'm not a sports guy either. Except for female sports. Those, I kinda like all of them. Yeah, this one's gonna be a pain to put in here. Ooh, stupid ball. Hey, Jack Faxon, how are you, my friend? Okay, I had to remove so I can actually insert it by hand because these things are too small and the insulation on these silicone wires, it's too thick. That's one disadvantage of them. So it's kind of a pain to these small crimpers. Yes, it's a BTT board. One done. Super cheap boards and they run super well. Can't complain. I have 6 on my Sila printer and not a single problem on any of them yet. Yeah, we have that, but I think we have that with every board, don't we? But yeah, they should use all the, I understand they want the smallest ones to save space, but okay, the motor you kind of need the pH for, because it's bigger current. I like they use these mini CB1. CB1 is the Raspberry Pi, right? Oh, sorry. Sorry, I didn't catch that Joseph was asking you. Pad 7, I haven't checked that. Understand is some kind of screen. That's good. Yes, it's a Voron anyway. It's well, it's kind of a Voron. It's a mini Voron. It's from the guys from Voron. Yeah, it's a Voron officially. It's a design from Voron. It's just not an official Voron. But yes, I printed the parts myself. Yeah, I print all my parts, well, except the first one I did. So this one doesn't really matter where I connect what, because it's ground and it's a switch, so it doesn't matter. Except my 2.4, which I don't have anymore. because I converted it into Scylla with 6 heads. It was the first one, and I ordered parts kit. I printed. Well, I ordered both kits, the printed parts and the hardware. Since then, all the printers I made, I print the parts myself. Okay, if I did everything right, we should be good. And I should be able to connect this thingy in here. And if I didn't, you guys gonna see some smoke. Let's hope not. Sometimes it happens. Nothing I can do about that. Is it well connected? I don't think so. Now it is. And this guy here on the top. And we should have everything connected. Except the USB. So the main connector. Okay, I'm gonna disconnect the beacon, the Carto for now, because we will need to program it. And yeah, we can leave everything else connected just fine. Motor, it's fine. Everything should be fine. We should disconnect the heater as well, at least one wire, and I will do that because we never know how the thing is going to be on. So let me disconnect one wire. No, Carto gets 5 volt. That's where I went through the I2C connector to get the 5 volt to Carto. And yeah, the Delta also doesn't. The Delta fan also gets 5 volt. So we did that as well. Yeah, it should be fine. Should be fine. Okay, let's go on. Now I think I need to. I don't need to, but I think I will. Mainboard, it's gonna be a Manta M8P with a compute model 4, so I'm not gonna use the CB. It came with a CB1, but I don't like CBs. I don't like to run Chinese firmware on my printers, which I have no idea what is it on it. So I like the default main branch of the OS. My V0 still has a CB1, but not for long. I need to change that thing. Okay, let me remove. For now, we don't need more crimpers. We were just doing this because it needs to be done anyway. We are not nearly close to the electronics. We have a lot of stuff to do before the electronics. How much for the cop? What do you mean cop? Ah, the compute model? I don't know, they are cheap now. Well, not cheap, but I'm from Portugal, so prices will be a little different, but they are... Let's check. Let's check. So where I ordered them? Mauser. So, yes, I'm human. Okay. So where are you? Where I am from? Compute model. So the one, so the compute model 5, it's so this is the light one. A compute model 4, that's 8 gigs, that's too much. About 50 bucks. So this is the one I'm running. It costs about 50 bucks. Euro and dollar, it's pretty much, but they are very close. So euro, it's a little stronger, so maybe 54 bucks, but probably you get cheaper in there. So this is the one I'm going to be running. 2 gigs of RAM, 8 gigs of flash, plenty enough, that's fine. And now you even have the compute the compute model 5s. They are a bit more expensive though. Don't we have a compute model 5 with 2 gigs of RAM? Only the light? Yeah, looks like it. No need for 5s anyway. The 4, it's way more than enough, so yeah, 50 bucks. It's probably the same as the CP2, and it's better. Okay, so let's take a look, since we are here. No, we are. Since we are here, let's take a look into the CAD. So I think we should assemble the... what should we be doing now? Let me turn off the panels. So panel assembly gone. Oh, I need to take a look into my gantry. Because I need to tighten the screws before I forget. So I'm gonna direct the gantry the best I can. Then when we do a manual change, a quad gantry level, we can do again when we know that the gantry is perfectly square. So let's do that. Oops, sorry, like that. Okay, so what I'm gonna do first, I'm gonna level best I can the gantry manually. So 165. 165. $165. There. I need to check my phone. It's been ringing all over. That's pretty much fine. Pretty much fine. Oh yeah, I love my... I never had a problem with... What kind of problems are you having? So... Try not to move the... Okay, this one needs more. But that's tightening the... No, actually it's good. Actually it's good. I'm gonna tighten it. Yep, we are good. We are very good. Let me... So we have this one on the bottom as well. Is it well bred? Is it cool? I never had problems with that. Make sure... And you never had problems with Linux PC? It can be the board processor, but if you don't have problems with a Linux PC, okay. And you tried a different USB port on a Pi? Yes, the 5 volt power, it's kinda relevant. That's why I like to set my... Actually, I should see on this motherboard the... Okay. It's not even the power. You just need to make sure it's more than 5 volt and you have thick wires. You want like 5.1, 5.2, 5.3 volts. I usually set mine at 5.2. Okay, so we have that done. So yeah, I think we should go for the what the fuck? Okay. Okay, so we need a red part. It can be a pi problem, it can be. I suggest you to try connecting on another USB port. That would be my first suggestion. I think it's this. Yes, it is. So yeah, we need the thingy. Oh, we need another red part, which is some kind of a corner. Nope. Yeah, this one. Okay, so we need our press, our fancy press. Yep, 2 amp. And preferably a little more than 5 volt. It doesn't like when the voltage drop under 5 volt, it doesn't like it too much. So I recommend something like 5 point. I usually set my 5 volt power supplies at 5.2, which I have no idea why the mainboard guys actually set them to 4.99 or closest to 5 as they can. stuff has a tolerance of at least 10%, so why not set them at 5.2, 5.3? Doesn't hurt, actually helps, and avoids a lot of problems. I had on my first 2.4, when I had a 2.4, I actually had a lot of warnings because of that. I have to, it's when it drops under 4.25, which it can happen very easily if you use thin wires, especially if they are long. If you use long wires and thin, it will complain when it's running on 2 amps. So if you have the 2 extra tenths of volt, so 5.2, it will compensate all of that. I'm not sure. I think I reduced quite a lot when I used the double power supply, the double wires on my initial 2.4. I'm not sure if I did that or I just assembled the 5-volt power supply that came in the kit. I'm not sure. I don't remember. When I changed to the Scala, I know I remember I did the voltage mod on my board, on my Octopus, and run it through, made it output 5.2 volt. I did a stream about that. Made it run at 5.2 instead, output 5.2 instead of 5 volt, and it solved everything. Okay, so we have this thingy, we have a screw in here. Actually, we have some white marks to remove. Let me turn on the... I don't want you to fall. Hot air station. Yes, I did it on stream, I believe, for Beanie, because I had a board of him to replace the CPU, and then I did the 5.2 volt mod on it. Yeah, I just changed one resistor and it solves it. Okay, so this one should be somewhere in here. M36, I believe. I know it's not a mod for everyone to do, but M3 what? I can't read. M38, okay. At least there is information on how to do it, if you decided to. Okay, I aligned with the hole in the panel. And the other one, according to the CAD, should be right here. I have two nuts somewhere in here. Or well, it's not the greatest idea as long as you have filters on it. But if you use filters on it, you should be fine. But you need filters. Make sure so give me a second and I'll show you what you need. The fuck? Oh, okay. Either the green donut or there are other stuff. You want, so I recommend you, where is my, so I'm gonna show you where I know where it is, where there is, not if you can get it somewhere else. You get, probably sure you can get it on the on Amazon or something like that. Look for ferret filter. Okay, so I like these ones, these split ones. They are easy to install. You just buy the ones according to the cable you're using. They are multiple diameters. You want it to close the closest you can to your cable. So use one after, so when it's leaving from the VFD to the motor, yes, and one on the motor end as well. Use two of them. And you want to buy one of these. One of these thingies as well, or this one, something like this. You can buy a bigger one, doesn't hurt. So you want these before your, so where you go in with 110, or I think it's 110 you guys have, right? So you want one of these before your VFD to the mains. You want one of these, the closest to the VFD as possible. And you'll see it will get, you'll get much better. So two of these, one off each end of the cable of the motor. So one next to the VFD, one next to the motor. And one of these to your right behind your VFD to the mains. I had problems on my router when I changed my mostly when I changed my VFD to a Chinese one. Before I had a Delta VFD with a Hertz motor. It was very good, but then the motor died, and I changed to I think it's a 4 kilowatt spindle, and I changed to a Chinese VFD, of course. I bought the set, and my end stops were always triggering and whatsoever. It was like, it looked like the damn thing was haunted, and or haunted or whatever. Haunted, I think it's how it's spelled, haunted. And then I use these filters. It helps if you use shielded cable as well, but I haven't. I used on my big machine, but not on the router. I placed the two split ferrets. Pretty much solved everything, and then I added the AC filter, and I never had a problem since. And it's a 4 kilowatt super Chinese VFD, which I bought it like, I don't know, maybe 5 years ago already. So it's not even like a new one. Probably the new ones are much better than that one. It's one of the regular one. Hello, Antonio. So it's pretty much the cheapest that is, and it works just fine. So yeah, just put some filters on it and you'll be fine. And I used it, the VFD, it's where the rest of the stuff is. If you want, you can always do some kind of cover of shielding, like a sheet box, metal sheet box, and isolate the back of the VFD if you wish. I'm not sure if you're gonna need to do that, and you connect that to to ground. But you should be fine with just the filters. But yeah, you could do that as well. Okay, so we are done, and it looks like we have another piece in here. Oh, it's actually that thing that I didn't knew what it was. My uncle bottle. So I know I have. Oh, it's this one. Well, if it has the shield stuff, then you just use the filters and you'll be fine. Yeah, that's red already. So we need another entry 8. Come on. Let's not. I need some zip ties. Yeah, that should solve your problems. I'm pretty... Will it grab? It doesn't. Shit, I need a bigger one. Let me grab some bigger zip ties. Will these ones work or they are the same? Shit, they are the same. So we need longer. Well, I have these that are extra long. I have another ones. The kit came with some very small ones. So I need to use either two or need to go downstairs to grab. Let me see if it's physical. Oh, okay. It's not. Not like that. Nope. Nope, it's impossible. So will I use two or... Okay, give me a minute. I need to grab some bigger zip ties. So give me a minute. Well, I don't need to do these now. So let's see. So for now, I need... Oh, these... Oh, they do. They do. So they wouldn't open. I think I'm gonna move this thingy a little to the back. Pretty sure I don't need a full size. So I need to move this thing all the way up. All the way up, and it can't go all that way up anyway, but so this pretty much connects there. Two links should be fine. Let's remove two links. Yeah, that's fine. It won't be able to come here because it's past the top already. So there's no way it's gonna go there. So yeah, this length is fine. I need 6 small screws. Like M3/4s or something like that. 3/5s. Probably I'll need to go downstairs for these. Maybe not. Fuck. Where did it go? Nope. One more. Yeah. I still cannot believe you found that machine on that price with the Mesa card. Was an absolute find. Hey Vinny, welcome back. I was looking into 5-axis systems because yeah, I could make my own, but there are some cheap solutions. But I would really like something with some quality. And I know I could buy a cheap one just to get used to it and then change to a better one, but I would prefer not to spend money twice. So I was looking into those that I show, yeah, that I shown on Discord, but they don't fit the Milo. That's the problem, because the Milo you only have, I think it's 126 millimeters of height, and those things are like 132, and they don't even have it's without the workpiece. So the main problem yes, they are NEMA 34s, but the main problem is because they have the motor behind the harmonic drive, so that thing has an harmonic drive inside. And if I could make them, then the main problem is just the C axis. The B axis, the A axis, it's fine. So basically, well, it's going to be the B axis. The B axis is fine. The only problem it's the C axis. If I can make it longer. My idea is to buy one of those and just either make new parts and gut that one or change that one. But I think I would make new parts to build it. So I could rebuild that same unit without messing with it. So the idea would be make it bigger and move the motor make it longer, not bigger, longer. Remove the motor from the back to the side, so we have the C-axis. I'm here. The C-axis in there, and move the motor to the side of the C-axis, and then use a pulley and a belt, because there's no problem using a belt on a harmonic drive. And no, because that thing needs to be mounted on a Y, because if you're using on the X, like on the X, let me put the main camera in, the front camera. Otherwise, if you put it on the X, when you rotate it to one side or to the other, you're gonna have problems of Y-axis travel, because the Milo doesn't have much travel on Y, so you would need to use it aligned with the Y, so it's a B axis. So if you use an axis on the X, you're gonna have an A axis, a rotation axis on the X. It's gonna be a axis. And if you use it on a Y, it's going to be the B axis. It doesn't matter, it's just a matter. So the B works on the Y, the A works on the X, and the C works on the Z. That's just what it is. So the idea would be using it like that, so it would rotate on Y, or for one side of the X or the other side of the X. Fine, doesn't matter. So if we can remove the motor from the back, we can move the whole thing down, so the side pillars could go way lower, like almost the size of the motor. We just need space for the belt with the pulleys. And then you would have the motor on side of the C-axis. Wouldn't be a problem, because you have the C-axis, you're gonna have the plate on top of the work on top of that, and that way you could save space and make the whole thing lower. So we have another type of, it's probably the type you have or something like you have. Let's put here 5. It's not writing. 5 axis CNC. Actually, it's looking for. Okay, so this is one of them, but this is not the one I said. This one is even better, but it's worse to work with. So this one, yes, this is a cheaper one. This one would fit on a Milo. The problem is the problem. It's not the motors. The problem is the system. The system, this belt system, it's not the best. I really don't like. I would really like to avoid this one. So I'm not sure which one do you have, I don't remember, but it should be something like this one. The problem is actually the belt system. The belt system sucks. It relies on the torque of the motor, even with the... yeah, even for aluminum it's fine, it's kind of fine. I have a 4-axis on my router, which is belt driven, and I made a lot of aluminum stuff with that thing. But you always have some vibrations. You can't really tighten the belt properly, especially with these systems that they make. But yeah, this one would work with Milo, and probably I'm gonna end up to buying. But I really would like harmonic drive driven version of it. So this one, it's actually very low. So this thingy has, I'm not sure if they have the dimensions in here. But I really don't like this. This sucks. And this sucks as well. But yeah, this would work on a Milo, and probably that's what I'm gonna end up with. I'm not sure. So yes, we have here, so we have 160 on the top, but that's not that important. Nah, I wouldn't trust a Milo to make well, I don't know, maybe my version of it probably would make it. Yeah, my version of it probably. I wouldn't trust the original version of it, though. Okay, but even this one has like a 160 there. But the lower point, this point in here, it's much lower. Just would be fun to play a little bit with 5 axes. Yeah, that thing. So that one, the one I showed on, I haven't found it yet. So let's look a little bit more. So there, okay. So probably it's gonna be here. Usually the guys that sell, oh, actually not this one. This one is also cool, but it's too high as well. It's just not double supported, which I think it should be. This one looks cool. Let's take a look. I haven't seen that one. I haven't looked too much into it, but... Fuck, where is... Probably should add a... Let me add a TH in here. It will help a lot more. Yeah, here we go. So... Yeah, that's the same version, just as the shock on it. If I'm gonna buy that one, it's gonna be, yeah, that one. Oh, whoa. I haven't seen this one. Shit, that's expensive. I haven't seen this one, though. Okay, so this is the one I shown on Discord. Yeah, okay, it's just... Okay, what's the height? We want... What matters to us is the fucking height. Yeah, 160... Almost 170, so that's a no-go. It's super expensive, though, this one. So this one is the one I was talking about. So if I made the, well, let's watch the video. Well, that thing is super cool. But yeah, this thingy, it has 132, so it's almost fits, but you don't even have the workpiece on top of it. So yeah, that's a problem. So I'm not sure even if I change it to be wider, remove the motor, still need to pass this diagonal, but we could round the corners to make it go lower. So this thingy is like, what's the width of it? So it's 100. It will always need something like 50. Yeah, the thing is, Milo is just too short on Z. I even considered, well, when you have a harmonic drive, it self-locks. When it's up, when it stops, when you have something with a gear of 50 to 1, it doesn't need, it's not locking in position. Those clicks were pretty much, I'm pretty sure he had some kind of signal generator, and those clicks was pretty much, I'm pretty sure he pressing the switch to generate the next pulse and whatsoever. Because when you have an harmonic gear, good luck trying to move this side, the torque side of the gear to the other side. I can't move my 4-axis is a 51 to 1 harmonic drive with a 150 shock on it, and with the whole thing disengaged, I can't move my by hand with the chuck. I can't move the chuck. I can't actually rotate the chuck by hand on the harmonic gear. So yeah, these ones look super cool. They are kind of expensive. You can get it a little cheaper than this, but it's like on the $900, and it's kind of a hit and miss to if I can make it fit. I thought about one thing. It was like increasing the column size of the Milo. I haven't thought through it yet, but I had that thought in my mind. I need to look into it to check that, because I would really like to make that thing move on 5-axis, and I'm willing to buy these, at least even that it is only to see what components, what size of drives it has on it, so I can then back engineer or reverse engineer a version of it that would work on Milo. So that's why I'm willing, and I can always use these on my big machine, even that I don't have 5-axis available yet on my big machine. It's a system that I'm pretty sure I could use on my big machine if I need to. I would need to do some changes on my controller, since I have my controller has 5-axis, but it's one of the axes it's used for thread, for tapping, for rigid tapping. So basically, when I use tapping, the spindle acts as a servo, and it's the C axis, but I can change that to I can change the tapping instead of that to follow, which means the Z will follow the spindle. It's not as precise as the system that I have now, but will be precise enough for what I do. So yeah, I'm seriously considering getting one of these just to see the insides of it, and we'll see after we finish the. After I'm gonna leave everything ready for like connections for 5-axis, because I think I'm gonna at least for 4, but I'm gonna leave everything ready for 5. It's just one more, it doesn't really matter. So if we pull the plug on it, everything is ready. It's just making the thingy and connecting it, and it's fine. So yeah. Anyway, back to the. Oh shit! It's time to finish actually. So I'm gonna finish the screwing in here. But yeah, I'm really into the 5-axis thing now. So one way or another, we're gonna make a 5-axis for that thingy. If we can make it on the machine itself, it would be even more cool. So we'll see. And I would really like something like the harmonic drive, exactly because of the torque. It's gonna be slow, but we don't need it to be fast anyway. It's a slow machine. Well, yeah, but that would make me go and explore other solutions like Mastercam, which is something that I actually would like to test and to learn. So yeah, if I'm going into the 5-axis thing, yeah, because it's no way I'm gonna spend the money they want me to spend on a subscription of Fusion. There are other ways. And I have friends with big shops that use Mastercam. I'm pretty sure I can get access to that if I need to. I think it's a little too tight still. Fusion extensions, it's stupid expensive, in my opinion. I really don't like that, but yeah. You can, but you can do indexing for free. You just can't do the full 5-axis thingy, but you can do it indexing with just fine. Let's say you need to machine one part 5 on 5 different faces. Let's say you have a square thingy, or a cube, not a square, a cube thingy that you need to machine on all 4 faces, or on all 5 faces, because you can't access the one where you're grabbing. You only have access to 5 faces on a cube with a 5-axis machine. You can't go to the lower one. So you can index it. So you can like, okay, I need to machine it like that, then rotate it like that and machine it like that, then rotate it like that and machine it like that again. And well, you can do that. You understand what I mean? So you can index it. So you can say, okay, I need to rotate X degrees and do a bunch of operations. Then I need to rotate a mount and do an X of operations. You just can't do like that, you know, the full axis thingy, you see? But you can index it with no problem. When you need to move all 5 axes at the same time, machining and what, for instance, like chamfering, like doing a 3D chamfering along a curve or something like that, then you need to rotate the machine. You need to move the z-axis, the x-axis, and or the whatever axis at the same time. When you need to move everything in synchronized, that you can do with the free license. But the indexing, when you need to, okay, I need to rotate the part X degrees and do whatever, and rotate it another X degrees and do whatever, and then rotate it X degrees on B and do whatever, that's perfectly fine. But when you need to do that flow, that 5-axis flow, everything moving in synchronism, that's where the shit eats the fan, and it doesn't work like that. So let's check some YouTube, since we are derailing already. I don't want to say accept all. So 5-axis machining. So these things you can't do. Let me remove the sound. But all that you can do. We want machining. Okay, that's not a good example. Okay, let's see, for instance, here. So here's this one you can do. That's fine. You can do this on the free license. You see, access everything. See, now rotate to the top and machine. You can do this just fine. Now these you can do. See, that you can do. You can do it like that, but soon as you get doing that, you can't do that on a free license. Like this, you can't do this. See? Everything moving together and rotating, and that's show off. You can't do that. But you can do that with Mastercam. Well, you need to pay it as well, but there's other ways, you know what I mean? And there's no other ways with Fusion. Anyway, so yeah, we're done for today. It's almost 1:30 a.m. for me. So we are done for here for today, and we are getting there. So next time we're gonna they didn't do a zip tie in here. That's weird. So next time, tomorrow, hopefully, we're gonna do the wiring of the top plate, or the top part, sorry, not the top plate, top part. So basically just running these wires down there, past the A and B motor wires through the thingy, and the can, the can cable, which is only 4 wires, and everything through here. So it's the X, the can, and the 2 motors inside this thingy. What more? Yeah, and then do the electronics. And so in 2 days we should be pushing plastic, right? If all goes well. So tomorrow, if we assemble if we do all the wiring, would be awesome. Then we can start on software. Well, I'm not sure if I'm gonna finish all the wiring because I want to do the lighting as well. I think I need to check if I have the parts for the camera. I'm not sure if I do. I'm not even sure what camera I'm going to put on this thingy. Let me check. I know I have the black parts for the camera holding, but I don't have the red part, so I need to print that. Panels, configurations, I would say next weekend. Should be ready by the next weekend. So yeah, probably Saturday we're gonna be finished. If everything goes well, it's pretty much all lined up, just a few things. Then it's hardware. We have some cool stuff for the hardware, configurations and whatsoever. So yeah, I would say next weekend. So what day is next weekend? So yeah, so I think we are on schedule. I said we should start the Milo after the end of the mid of the month, and since we are, I believe we're gonna be finished by Saturday on this thingy. So let's hope so. Then I need to clean up my down shop, and we need to start building the Milo. I have pretty much everything. Well, I don't have everything. I need to order the panels. I ordered the frames for the enclosure. I need to cut them since they were on promotion on Ratrig. I ordered everything, all the frames. It was kind of expensive. Cost me 165 euros the full. If I made my math right, it cost me 162 euros all the frames for the enclosure. I need to buy the panels yet. I haven't bought that. I bought all the hardware. I've been working on the telescopic wakeovers, which should be fun, but I need to do some test printing and whatsoever. Yeah, should be a fun project. Then we're gonna do a mix probably. We're gonna do. I want to do the next after Milo. I want to do that robotic arm. That would look so much fun. I want one of those thingies. So yeah. But probably we're gonna use Milo to do some stuff for that, and then we're gonna start some other series of machining in Milo. When we go where we're gonna have CAN and CAD and work holding solutions. Some fun. Some of those tricks of machining. That's the only idea of making Milo, is to actually do some machining on it and some lessons on machining. I really want to put the 5 axis. As you guys seen, I'm kind of commit to that. I want to have some fun with that, because I never worked with 5 axis, so it's going to be a learning lesson, a learning curve for me as well, but should be fun for us to have it together. Just some cleaning some sticker in here. Anyway, so that's it for today, and we'll see you tomorrow. Thank you guys for making me company and watching. So see you guys tomorrow. Have a nice end of day. Good night to everyone, and see you tomorrow. Bye bye. Love you.